In this video, I will discuss a JEE Advanced PYQ from the topic ray optics. This question is based on Snell's law and geometry. Snell's law states that the refractive index of second medium with respect to first medium is sin I by sin R. The light is traveling from the first medium to the second medium. This is the normal. This is the incident ray. And if this is denser medium, second medium, so we'll go closer to the normal. So I, this is R. So refractive index of the second medium with respect to first medium is sin I by sin R. So if this is greater than 1 means I is greater than R. And suppose this is a glass slab. And suppose this is air. We can also get the distance from the point where it is incident to the point where it's coming out. This distance as, suppose the thickness of the glass slab is say D, and this is R. So this will be D tan R. So with this understanding, you can solve this JEE Advanced question. Question has appeared in the year 2022. Timestamps are given in the description box. You can watch parts of video if you're running short of time. This is the question. Consider a configuration of n identical units, each consisting of 3 layers. The first layer is a column of air of height h equal to 1 by 3 centimeter, and the second and third layers are of equal thickness d equal to root 3 minus 1 by 2 centimeter, and refractive indices mu1 equal to root 3 by 2 and mu2 equal to root 3 respectively. A light source O is placed on top of the first unit as shown in the figure. A ray of light from O is incident on the second layer of the first unit at an angle theta equal to 60 degrees to the normal. For a specific value of n, the light ray emerges from the bottom of the configuration at a distance L equal to 8 by root 3 centimeter as shown in the figure. The value of n is dash. So this is the figure. You can pause and attempt this question. So it has got 3 layers. The first layer is air. The second layer has got refractive index 1, mu1, and the second one has got refractive index mu2. And this is root 3 by 2, and this is root 3. The refractive index here is 1, so this is square root of 1.5. So this is denser compared to this one. This 1 is same as square root of 1, and this is square root of 3, which is more than this one. So this is still denser. So the light ray will go closer towards the normal compared to the and here we will still go closer to the normal. So this angle is angle of refraction in this medium. Then we call it theta 1. This is theta, and similarly this angle with the normal is theta 2. Okay, so this is one unit, air, glass, sorry, medium 1, medium 2. So the total shift from here to here when it passes through one unit is, this distance is given as h, and this is d, and this is d. It's given in the question. So this much is h. This angle is same as this angle, parallel lines, alternate angle. So h tan theta, this much, and from here to here, it is d tan theta 1. This is a right angle triangle. So tan theta is this by, tan theta 1 is this by this one. This is D. And similarly this one, from here to here, it's same D tan theta 2. So total shift from here to here is H tan theta plus D tan theta 1 plus D tan theta 2. This is through 1 unit. So H tan theta plus D tan theta 1 plus D tan theta 2. H, D are given in the question. So you have to find theta is also given at 60 degrees. So you have to find theta 1 and theta 2 using Snell's law. So Snell's law of this interface, refractive index of this medium with respect to air, which is 1. So that is mu1 by mu air equal to sine I, which is sine theta by sine theta 1. So mu1 is root 3 by 2. Mu of air is 1. Sine theta is sine 60. It's root 3 by 2 by sine theta 1. So this means sine theta 1 is 1 by root 2. Root 3 and root 3 will cancel. This root 2 will cancel root 2 here. So remaining root 2 will be there. So this means theta 1 is 45 degrees. Now we have to find theta 2. So again, Snell's law of this interface. Refractive, so this second medium mu2 by mu1 equal to sin I by sin r. So this angle and this angle is same, theta 1, alternate angles. So at this interface, incident angle is sin theta 1 by sin r is sin theta 2. Mu2 is root 3 and this is root 3 by 2. So root 3 will cancel. So it will be root 2. Root 3 and then root 3 by 2. Root 3 will cancel. Remember there is root 2, so it will go up. That's equal to sin theta 1, which is 1 by root 2 by sin theta 2. So this means sin theta 2 is half. That means theta 2 is 60 degrees. So use these two things there. So this is the total shift when it passes through 1 unit. So H is 1/3, which is 1/3. So shift when it passes through 1 unit is, which is 1/3, and then theta is 60 degrees. So tan theta is root 3, and then D is root 3 minus 1 by 2 into tan theta 1 plus tan theta 2. D I can take commonly outside. So tan theta 1 is 1, and then theta 2 is 60, so it's root 3. So this is 1 by root 3 plus a plus b into a minus b. So it's a square minus b square. It's 3 minus 1, so it's 2 by 2. A plus b into a minus b. So a square is 3 minus 1, so it's 1. So this is 1 by root 3 plus 1. Here there is a mistake. Theta 2 is 30 degrees. Sin 30 is half. So theta 2 is 30 degrees. So this will be tan 30 is 1 by root 3. So this will be root 3 plus 1. So that will be 2 by 2 into 1 by root 3. So this is 2 by root 3. So this is the shift when it passes through 1 unit. And the total shift after it passes through n units is 8 by root 3. So this multiplied by n should be equal to 8 by root 3. That means number of units is 4. 4 is the correct answer. So this is what is explained here. So this is one single unit, air, medium 1, medium 2. So here it will go towards the normal because this is denser medium. So the angle theta 1, which is less than theta, and here is still reduced to theta 2. And the shift from here to here is, this is h, so it's h tan theta. This is d tan theta 1, this is d tan theta 2. So total shift when it passes through 1 unit is h tan theta plus d tan theta 1 plus d tan theta 2. Theta is given as 60 in the question. Theta 1, theta 2 we can find by Snell's law at interface 1 and 2. So at interface 1, it's between medium 1 and air. That's equal to sin I, which is theta, and sin r is theta 1. Mu 1 is given as root 3 by 2, and theta is 60 degrees. So sin theta is root 3 by 2. So from this, theta 1 is 45 degrees. At the second interface, refraction is the second medium is for the first medium, which is sin I, which is theta 1, by sin r is theta 2. This is root 3 by root 3, root of 3 by 2. So root 3 will cancel, will become root 2. So root 2 equal to sin theta 1, it's 45 degrees, so 1 by root 2, and sin theta 2. So from this, theta is 30 degrees. So once theta 1, theta 2 are known, we can use this thing. So h tan 60 is root 3, and then d tan theta 1 is 45, theta 2 is 30 degrees, so 1 by root 3. H is given as 1/3, so 1/3 into root 3 is 1 by root 3, and d is root 3 minus 1 by 2 into 1 plus 1 by root 3. So simply we get 2 by root 3. So this is the shift when it passes through 1 unit. Through n units, the shift will be n times this one. That should be equal to 8 by root 3. That means n should be 4.